So where were we? So first one, injection. So injection flaws are very common in applications today. These flaws occur because user-controlled input is interpreted as an actual command or a parameter by the application. Injection attacks depend on what technologies are being used and how exactly the input is interpreted by these technologies. Some common examples include SQL injection. This occurs when the user-controlled input is passed to SQL queries. As a result, an attacker can pass in SQL queries to manipulate the outcome of such queries. Or command injection. This occurs when the user input is passed to system commands. As such, the attacker is able to execute arbitrary system commands on the application servers. If an attacker is able to successfully pass input that is interpreted correctly, they would be able to do the following: access, modify, and delete information in the database when the input is passed to database queries. This would mean that the attacker can steal sensitive information such as personal details and credentials. Execute arbitrary system commands on the server that would allow an attacker to gain access to the user's systems and would enable them to steal sensitive data and carry out more attacks against infrastructure linked to the server on which the command is executed. The main defense for preventing injection attacks is ensuring that the user-controlled input is not interpreted as queries or commands. So you've got input validation is the key one there. There are different ways of doing this. Using an allow list, when the input is sent to the server, the input is compared against a list of safe input or characters. If the input is marked as safe, then it is processed. Otherwise, it's rejected and the application throws an error. And stripping the input. So if the input contains dangerous characters, these characters should be removed before they are processed. Dangerous characters or input is classified as any input that can change how the underlying data is processed. Instead of manually constructing allow lists or even just stripping the input, there are various libraries that can perform these actions for you. Okay. So, command injection. This occurs when the server-side code, like PHP in a web application, makes a system call on the hosting machine. It's a web vulnerability that allows an attacker to take advantage of that made system call to execute operating system commands on the server. Sometimes this won't always end in something malicious like "who am I?" or just reading lines of a file. That isn't too bad. But the thing about command injection is it opens up many options for the attacker. The worst thing they could do is spawn a reverse shell to become the user that the web interface, the web server, is running as. Simple nc e bin bash is all that's needed and you own the server. Some variants of Netcat don't support the E option. You can use these reverse shells as an alternative, and then this is a link to payload all the things. So here we've got like all the different language options. So if you found a Python server, you can run some of these against. So yeah, good. What else they got? PowerShell. So yeah, if you can access PowerShell, you can run this to get a reverse shell on that box. Once the attacker has a foothold on the web server, they can start the usual enumeration of your systems and start looking for ways to pivot around. Now that we know what command injection is, we'll start going into the different types and how to test for them. Cool. Right, so our first practical. So let's start the machine. All these toasts. So what is active command injection? Blind command injection occurs when the system command made to the server does not return the response to the user in the HTML document. Active command injection will return the response to the user. It can be made visible through several HTML elements. Let's consider a scenario. Evil Corp has started development on a web-based shell but has accidentally left it exposed to the internet. It's nowhere near finished but contains the same command injection vulnerability as before, but this time the response from the system call can be seen on the page. They'll never learn. Just like before, let's look at the example code from evilshell.php, go over what it's doing and why it makes active command injection. See if you can figure it out. I'll just go over below. So we've got PHP open bracket, like the open PHP shell. If command string is set on the get parameter, then it stores the command string. Try pass through command string, otherwise error. So you're getting an input, immediately using it, and then, yeah, that's just not good. In pseudocode, the above snippet is doing the following: checking if the command parameter is set. If it is, then it passes it from the input field. The program then tries a try block to execute the function. You can read about pass-through on PHP's website. So let's do that. So pass-through, similar to the exec function, that's always good, in that it executes a command. This function should be used in place of exec or system when the output from the Unix command is binary data, which needs to be passed directly back to the browser. Common use for this is to execute something like pmb plus utility and can output an image stream directly by setting the content type to image GIF and then calling a pbm plus program to output a GIF. You can then create PHP scripts that output the images directly. So it's basically exec, but it does some kind of sort of like a nice HTML parsing, I guess. Or at least just it must convert some of the binary into some kind of encoded variant that the browser will display. So if the try doesn't succeed, it will output an error to the page. Generally this won't output anything because you can't output standard error, but PHP doesn't let you have a try without a catcher. Okay. Oh, PHP is so shite, I don't know why anyone uses it. Hopefully no one uses it in like prod systems nowadays. Alright, where's my attack box? Alright, ways to detect the active command injection. We know that active command injection occurs when you see the response from the system call. In the above code, the function pass-through is actually doing all the work here. Yep, we just got that from the docs. It's passing the response directly to document. You can see the fruits of your labour right there. Since we know that we can go over some useful commands to try and enumerate the machine a bit further, the function call here to pass through may not always be what's happening behind the scenes, but if I felt it was the easiest and least complicated way to demonstrate the vulnerability. Here's a couple commands to try. So here am I, the ID, ipconfig, IP address, username, psef, and then some Windows variants. So let's navigate to that evil shell. So let's literally do it as it says to do it. Let's give me a new window. There we go. So who am I? Submit. www data. ID. Then we get the UID. ipconfig /IP ADDR. Okay, that one didn't do anything. Let's try again. Oh, it did ipconfig.ifconfig. That might help. No, okay, that one doesn't show anything. We get anything back? Doesn't look like it. We do. Yeah. So if we do uname-a, Linux injection, generic Ubuntu, so we get some server info, and then PSEF. Get a nice dump of the PS file. Right, so what strange text file is in the website root directory? So I guess we're not going to see that here. So what would we do? Let's do ls. This gives us the current directory. So if we want to do cd dot slash and ls html. Oh, it's in the web root, so cd backups, cache, crash, so we've still got to go up one. Well, I guess they just want that, don't they? Dr. Pepper txt. So yeah, we don't actually need to go up directory shit. So Dr. Pepper txt. How many non-root, non-service, non-daemon users are there? So let's pop that back in. It's everyone's root. root. Who isn't root? Daemon. www data was root. Is it the one? No. Is there a nice way we can get that? So this should be like a count. Yeah, I know you can get it just by reading it. I want like an actual count though. This output shows multiple entries for the same user in addition to no login. No. Guess we could just do cat etc. Let's make it full screen. Not going to let me edit you. It's slightly easier to read it. So we've got root, daemon, bin, one of the options we're not allowed. How many non-root, non-service, non-daemon users? Root. Does no login count? I guess not. So we've got games. These are all no logins though, so proxy, www data, it's no login, no login, no login, no login, no login. Oh, nobody, who's that? Gnats bug reporting system. Yeah, it's a bit strange how you're supposed to recognise that at a glance, which are the non-root ones. See, that is enough. I guess. Right. Zero? Is that? Yeah. So they're all root, service, or daemon accounts. I'm assuming that just means that they're all non-login. So you don't have any users, it's just root. Ooh. So which user is the app running as? That was www data. That's hyphen data. What user's shell? What is the user's shell set as? So where do we get that? Get a shell name. PSP $$ or echo shell. That's not right. Let's do the echo shell. Echo 0. Sure. I mean, that's blatantly wrong, so it doesn't fit the format. Echo shell, we tried that one. You don't work. To find the PID of the current instance of the shell, so what? Just it. So he's doing like one line, it's just not showing. There it is. Yes. So 140. Isn't even in the list. Now shell gives you so shell, but then what do they want for the cat shells? I think bin shell. What is the user shell set as? Alright, do you have to get that whole format? CD. Which user do they want? What's the user cell? Right. this. Get users home directory. Oh, yeah. Use eval, yeah, great. That did work. So www. Get users shell. It's not going to be the bloody shell because it's HTML. That's just going to be the root directory of the web server. So, well, it's just going to show a load of crap. What do they mean, evil shell? No. It's okay to know that. www data, put some spaces between the pipe. No, how are you supposed to get that exact format? The greps don't even work. User bin no logon. Right, cool. So we got it in the end. So what did that look for? Orc F. I've never used that before, so what sound does that do? Syntax. Oh, just give me a man file, for fuck's sake. So field separator -v there's no V on there. It's just so orc user that user print. Oh, is it just getting the etc password? So in theory, I could have just done what I did earlier, and then just find www data and just strip it straight out of there. So that bit. Cool. All right. What version of Ubuntu is running? What will we use for that? Get Linux version. Uname R. Let's get the OS release then. Ubuntu 18.1 LTS. Guess it just wants that bit. So submit. Print out the message of the day. What favourite beverage is shown? Okay, so just that message of the day. Yeah, in fact, you get message of the day. etc motd. Cat etc message of the day. Yeah, so how can I get that to display forcibly if it won't print? Looks like it was changed. There is no etc motd. You can do cat var run. Okay. No, you can't. Alright, how to use method of... As of Ubuntu 19 is now a cat. No, it's not. Just use a bash script to get it. Okay, that worked. Right, so what the hell did that do? In etc update message of the day, do if fsoc at reboot, then so it's like fetching it. The scripts under update message of the day are what provides the typical output shown upon logging in. There is little to no need to reinvent the wheel by scripting it yourself. Use run parts 8 instead. Okay, so it's a different location. So that should do the same thing, which it does not. Well, that's quite cool anyway. Like running a proper bash script in the command injection. So what was the answer? Print out the message. What is the favourite beverage? Yeah, I can't see it. No. Escape sysinfo. I mean, that does something. You get an output. It doesn't print out a beverage though. These don't print anything. Could run landscape sysinfo. Right, doesn't do shit. Okay, that does. Poor man's brute force. And I mean, I'm not seeing anything there. Don't know. Is it a thing here? Is it? Yeah, is that supposed to be the message of the day? They're not actually on about the Windows thing. What was the hint? OO header. ETC, yeah, we looked at that. It didn't bloody work, so we tried that. Where did it get? How are you supposed to know that OO header was a thing? That's just really annoying. Just let me fucking copy it. Doesn't even output anything. File names are named NN description where NN is the ascending start order. I mean, it doesn't. Cat etc update mod. That's exactly what I put in. Update. .d. So there we get that. Dr. Pepper makes the world taste better, but again, I'm not getting header. What's the cause of that? File names are named NN description where NN is the ascending start order. Okay, so it's just the format of the message of the day. So you have the header, something else, whatever else you want to build it.